All right, so IoT vulnerabilities. First off, let's just do the real quick introductions. He already said who we were. He read all that great stuff. I wrote the bio, so I might have been a little lavish on renowned speaker. I don't know, something like that. Yeah, you guys are tough. Wow. Bottom line is we've been doing it a while. We're going to talk about IoT vulnerabilities. Everybody knows what the Internet of Things is, right? We have in my own security practice, I'm the CTO and managing partner for Mad Security. I oversee the assessment team, the red team, the managed services, all the professional service, things like that. We have seen a huge uptick in IoT devices in just the last 24 months. I know they've been out there everywhere, but in enterprises, they're just not super common. People were not letting them on the network, but now we're seeing them all over the place. So these are often unhardened and ripe attack pathways into your networks that just aren't known. And suddenly everything has an IP address. And I laugh about that, but I literally had to go from a Class C network into multiple Class C networks because things like my treadmill at my house has an IP now. Anybody else have that problem? And I have 4 kids, and each one of them have like all these devices as well. So it's getting kind of ridiculous. Anyways, so we did this little project here. This is, like I said, my 9th, I think this is the 9th Cyber Summit, right? Is that right? 9th Cyber Summit? It's my 9th time to talk to you guys. And this year it was kind of cool. They said, hey, do you want to speak? And I said, sure. And then they sent me my topic, which was, hey, do vulnerability exploitation on IoT devices. Like, okay, I guess I better do something. So I didn't want to share like exactly what I was doing in our commercial practice and stuff because that's just not fair to customers, things like that. So I said, hey, how can I represent what we're seeing across the board and still have some kind of randomness to it, have some kind of legitimacy to the project. So I decided, hey, we'll do about a week's worth of effort, me and another engineer or a couple engineers, whatever it is, because we can't afford to have them, just goofing off like I do all the time. We'll spend about a week, and I'll spend less than $100. And so I went on Amazon, I typed in IoT, and the first few things that came up were smart plugs. You guys know what a smart plug is? It's a little device. We actually have one sitting on the desk over there because we're going to show a little hack on it. But what it is it plugs into the wall, and then you plug a device into it, and you can turn the power on and off. You can measure the current, you can see all these cool things, stuff like that, right? It's a not very like sexy cool thing like a computer or something, but it has an operating system on it. It does those things, and it has a simple functionality. They're fairly cheap. They range from anywhere from $15 to $50 a piece, so it was well within what I was trying to do here. And the goal was to just see what we could find, nothing fancy, but wanted to show common security-related issues with IoT devices. Because what I have found with IoT devices, and also testing in like commercial manufacturers, SCADA, those types of environments, is some of the problems are, well, actually, a lot of the problems are identical for these like little shabby-like devices like power plugs and teddy bears, and everybody talks about security cameras. So I mean, that's those types of things. But they're the same as for these big giant implementations of like controlling robotics and manufacturing cars and things like that. They're using the exact same operating systems, the same protocols. They're doing the same kinds of things. All right, next slide. So the very first one was the Cancun smart plug. It's literally $27. You can get it at that URL there if you want to go buy one. Some of the features it had was remote access for both Android and iOS apps. 802.BGN, had scheduling and away stuff. And the very cool thing about it is we found out it is running an operating system called OpenWRT. Anybody know what that is? Yeah, it's very popular in routers, wireless things. You can reflash like Netgear, you can reflash Linksys, stuff like that. It's extremely popular. It is also extremely popular in the embedded system stuff like this, right? Why? Because it's open source. Everybody's seeing it, and it's it's got a bunch of features. It's easy to keep up to date. It's everywhere. So it's kind of a cool operating system. So actually, Scott here did most of the testing on this device, and he was just like all giddy. The first thing we wanted to do in any testing, anybody do any security testing? Themselves? Wow. You're all alone. I don't do it either. I just kind of direct traffic, like the air traffic control guy. So the very first thing you want to do when you test any kind of device is like, okay, what does this thing do? So we mapped out what this thing did to communicate. He turned it on. It reached out and said, hey, Beijing, I'm here. That was kind of cool. Don't know what else it does with that, but it does have HTTP traffic to Beijing. It syncs itself up. It's kind of cool. Registers itself. It also talks to an AWS cloud service. It's got a cloud service, and that's actually how it controls the phone. It's over port 45389 or 398. See, I've been all backwards, dyslexic. Anyways, it shoots commands from the smartphone. It also, the interesting thing is we find this vulnerability a lot in IoT devices, in SCADA environments, in industrial control system, in just all these implementations. They like to do what we call a persistent connection over the UDP protocol. So that Cancun device is that power plug down at the bottom right. The AWS cloud's on the internet. What's in between AWS and that Cancun device on every network? Does Cancun have a public IP address? No, right? It's going to have a private IP address. What silly person would put that thing out on a vendor? Nobody, right? So there's a firewall in between there, right? But if the Cancun device is going to receive its commands from AWS, how does AWS send those commands to it? It can't, right? Because it can't reach it. There's a NAT table, there's firewall blocks, it can't do that. So all the guys know this. What protocol does a firewall have the most trouble keeping persistent state on? Well, a stateless protocol, right? Is UDP stateless or stateful? Stateless, right? So it has to put this pseudo algorithm into the firewall that says, hey, this connection's open. So what they do is they send a heartbeat, a UDP heartbeat, out on this port to AWS and says, hey, and the firewall says, well, if I let you out, I gotta let you back in, right? That's how it works. It's just how this stuff works. So that's how they create a backdoor channel into your network so that you can control this thing with a smartphone. What is wrong with doing that with a stateless protocol? You can't authenticate both sides. So can I spoof UDP packets all day long? Yeah, so you're going to find the hacks that we do right here. All we literally have to do is write a little script and blast it to the internet, and we could probably turn lights out all over the place because it doesn't know it's not coming from AWS. You guys giggle, but it's true. And then the other cool thing we found was, look at that protocol going into AWS. Why would I go and enumerate the entire internet? That's going to take too long. Why not just send every possible IP address to AWS and let AWS turn everything off? It's pretty good, huh? Anyways, so that's why we want to show you the communication channels. All right, so next slide. So the first thing we did was he opened up the binary. Well, you're doing a lot of talking. He looks pretty though, right? That's what testers do. They look pretty. He's my Vanna White. He's even blushing. That's why he has the beard. So we analyzed the protocol. We found out, hey, it's got this shared object, does AES encryption. He found the key. That's interesting. So there's thousands of these devices, and there's an embedded key. How hard would that be to update and patch? Well, not too hard, since you got a backdoor via UDP channel. You can just push it that way, I guess. Nah, you guys are not tracking, are we? I might have to take an hour to talk. I don't know. I'll slow way down. Anyways, so he pulls out the key. We found out it's the JNI encryption functions. We analyzed it, produced a matching encryption key. We just sucked it out of there. Now we can decrypt all the traffic over that UDP channel. He looks at it. Hey, this is the C2 script, right? Takes that encryption key. He looks at the traffic that's going across the board, and we find a command structure. It has the phone name, the device MAC, the password, the command, and the request. As you can see, there's the hexadecimal value on the left, which is cool for geeks. And then there's actually what you would see if you decrypt it on the right. And he's got the LAN name, the password, and all that stuff. What does that mean? That means with that key, if we capture any of that traffic, no matter where it is, from any one of these devices, and now this is just a plug, and let's always represent that this plug represents what most other IoT devices do out there, whether it's a fridge, a kettle, a robotic control system that builds cars, or stuff like that. They all kind of do the same thing. If you find that static key in the binary of the code, you can decrypt everything. And that's what he's showing here. So we decrypted this. And remember, we did all this within 30 hours, 40 hours of work? We literally didn't try all that hard. I think we were giggling more than we actually did working. So what else did we do? The password encryption. So what if the encryption password is used? The Cancun app offers an additional encrypt functionality. It actually has a string added to it where you put the password in the encryption. So luckily for us, we found that you can request packets sent to a broadcast address on UDP port this, and by sniffing that traffic, you can produce packets when a command is sent to the plug using the static that key. You can see that password, and now you have the password there, and you can decrypt those traffic as well. All right, additional things we found. We found that SSH is enabled by default, but not documented, which is kind of cool. And the default password is admin1234RP9Z34C. Our device was configured with P9Z34C, which is kind of cool. The easiest exploit that you can do on any OpenWRT device and keep a persistent thing going there is a make node pipe to telnet backdoor. So you don't have to install anything, and now you have a backdoor tunnel back into it just like you would that UDP channel to anywhere in the world, and you can issue commands for it. Why is that important? Who cares about taking over a plug, right? Oh, wow, you hacked my plug. Who cares? Well, I just hacked your plug, which is sitting on your internal network, which has access to whatever else is there, right? So we've just gotten past all those boundary defenses and things, and it becomes a pivot point into your network. Something that we thought would be kind of cool, well, I won't get there yet. Custom version of OpenWT can be reflashed with malware that connects back. So when we were doing this, I was thinking, hey, what could be kind of cool and sexy with these like little plug things? I was thinking, well, we're going to add this to our red team assessments. You guys know what red team is, right? That's where we like try to be really incognito, and we do things like phish you, like because it's so technically hard to send a thing saying that you just won $1 million and click here, right? But we wanted to add to that toolkit, and I was like, you know what would be really cool is if we could reflash these devices, put our logo on the side of them, and ship them to people and be like, hey, Mad Security loves you. How don't you plug these plugs in, right? Or take them back there to the booth, and as you walk by and you get in your fidget spinner, be like, hey, Mad Security loves you. Here's these plugs. Well, we found that because it's just a generic operating system, all you got to do is reflash it. We could basically recompile OpenWRT, put it on a system. When you did your hardware reset, we're still persistent because it's our operating system with our backdoor. That's kind of cool, huh? Let me ask you this. When I ship it back to Amazon, what are they going to do with that device? Oh, I bet they factory reset it. Who cares? It's my OS. They'll sell it to you refurbished. That may be the works of a new project of mine. It's fun sometimes. Here's a TP-Link HS100. Again, 3 devices, 30, 40 hours worth of testing. You're looking at about 10 hours worth of testing each. Understand that was our timeline. So $29.95, I mean, TP-Link gets their money's worth for this plug. Same kind of things, remote access, scheduling, and it works with Amazon Echo. Anybody got one of those things? I love mine until I'm on a conference call and it just starts talking to me. I'm like, oh my God, it's like the NSA. Oh, you guys are catching it now. Somebody woke up. The NSA is mad because now I know about the Echo, right? Perfect device, right? Wow. Scott, are you laughing? Oh, wow, that's awesome. He's doing really well, right? He gets like super nervous, just so you guys know. Yeah. So he told me I could talk the whole time. All right, so this is the TP-Link conversation. It actually does something better. It uses the protocol TCP. Right, that's a good thing. Don't use UDP for your command and control. I know it's lightweight, it's easy, it's robust. You can use a small stack. Use TCP if you're going to design these things. If you have these things in your network and it's not using TCP, like throw it out, get another one, because it's just, there's no way to secure it. You can do all the testing you want. You can do all the patching you want. You can do all these things. The UDP protocol is susceptible to spoofing. That's just how it works. So it does TCP. It talks back and forth to AWS Cloud. It talks directly to it on port 999, and it also has a little persistent connection on those other 2 ports there. I forget which one's command and control and which one is like, hey, I'm just chatty heartbeat, but one of those ports, I think 45123 is command and control, and 5443 is the heartbeat. The really important port is that 999 straight to the plug over the wireless network. It actually controls it. So this one, we kind of took the shortcut. We Googled it. Aha, right? Google. So in Google, we found that somebody already did all the freaking work for us. We were like, holy cow. So we just downloaded these tools. TP-Link smartplug.py, it's a Python client to control a smart plug. TP-Link smarthome.lua, a Wireshark dissector for the encryption. The TDB client, which is a debug protocol things. And goodies in the pull requests and also the issues. Anybody that goes and gets these hacking tools or scripting tools, I tell folks all the time, it was really sexy that somebody uploaded that thing and put it in GitHub, but go look at all the other smart people that actually did pull requests and said, hey, you might want to add my patch, or hey, I had this issue with it. Why? Because they took whatever it was and like really polished it up. So when you guys find these like hacking tools or your favorite tool to do things or testing, go look in the issues section in the wikis and go look in the pull requests, because I'm telling you, there's always really cool stuff there. And I found some really cool stuff in that area. I'll show it to you here in a second. Anyways, so this device says I use really cool security. I don't use AES, I don't use DES, I don't do any of that stuff. Like, it doesn't matter. I XOR. And I XOR with 171. And I'm TP-Link. And this is how you decrypt it, and this is how you encrypt it. It's that easy, right? Oh, they did use progressive key, right? So it's the auto key, which means 171 decrypts the first byte. Whatever that decrypts to actually decrypts the next byte. So you kind of have to write a for loop. Oh no, right, exactly. And you gotta make the key from what you just read. I mean, it's instead of a for loop with just one line or two lines, it's 3 lines. All that extra typing makes my fingers hurt. So here's Wireshark, and it was already built for us, so we didn't have to do nothing. We could just see the command and control stuff, right? This is turning it on, this is turning it off. You can see the decryptor. Anybody use Wireshark? Yeah, it's kind of cool, right? I mean, we literally just plugged the plug-in in, pushed the button, and was like, hey, look, this thing, we can see all the traffic. So we didn't put much effort in this one. Here are the commands that you can do with this device. Something that you should be very apparent to, and that I want to point out with IoT devices, is it is important to do what I just said in that project that I may kick off really soon, is how these devices actually get firmware and how they qualify that firmware. Because if it has commands in it like this one does, it's not on there, is it? It's, I think it's like system flash, and you can like remote flash it with the URL and stuff. If I'm able to hack a device or create something that hacks it and reload the software on there, it's no longer your software, it's my software. I can put whatever I want in there. And I actually think that that's one of the biggest security risks that we have to IoT devices. Is it's cool that somebody create a worm and log into it and use it to pivot in your network and stuff, but what happens when they log into it, update it with their software and let it go? And then when you hit factory reset or you hit your updates, we say, yep, you're updated, and I changed the version. How do you actually have proof that that code is the real code, the good code, those types of things, right? That's the real risk. If I can automate that, that's a bad thing. And every one of these IoT devices I've tested seems like that's a legitimate attack. I just haven't done a whole bunch of research into it. But that's where my brain's kind of going with this. Maybe I can click again. There it is. Additional info, firmware flashing tool by TP-Link. They actually give you a tool to flash it. So if you did hack it, you could actually flash it with their own tool. It's a little script. TP-Link uses code on smart bulbs too. This was cool. So, and they use the exact same encryption key. So all the lights, the smart bulbs, not just the little power plugs, use that encryption key as well. You're doing awesome, Scott. Galaxy Win Smart Plug. This is the device number 3. How are we doing on time? Good. Oh, cool. 7 minutes. This is $29.95. This is a little more expensive. It has the same kind of things. It had usage history for electricity, which is kind of cool. This is how it talks. It uses a persistent UDP connection again. Anything, and you're going to find this in all the IoT devices. My freaking iFit scale that talks out and tells me how big I've gotten uses this protocol. My treadmill uses TCP. I just got devices all over. But a lot of them use this UDP protocol. So be very, very cautious of this. And when you guys are sniffing packets like in your enterprise network and stuff, anything that's like devices making these heartbeat things, that's what they're doing. Is they're building backdoor tunnels into your network because it's command and control. This is how malware does it. This is how legit stuff does it too. All right, so the funny thing about this thing is it uses this new really cool protocol called Probe Me, which basically barfs the wireless SSID and password on initial configuration 1,000+ times to the clear text network. And what this is it solves a problem. It is a pain in the rear to plug this device in, hold it down, get it to open up its own access point, punch in my code here and say, hey, this is SSID and all this stuff. So what they said is that when you have 1,000 IoT devices, this is what this protocol is meant to do, and it's a legitimate protocol, is you have 1,000 of these IoT devices or 10,000 of these things, you put it in a mode, you push the button, then you run this application and you say, configure me, and it blasts this password out and the wireless SSID so it can join to the network and be on your secure network to everything that's receiving so they can be configured. And instead of configuring one-on-one, taking 10 minutes for each, it takes 10 minutes for all of them. So it solved a real problem, and then it also put your password and SSID out there. Why is that bad? Because that's your password and wireless SSID, right? So now I don't have to like hack the device, I just log into the network, right? Makes sense. This is a legitimate protocol. It is a new protocol, and it's used to solve a bunch of industrial control things. It is not just for IoT. You can go Google it and figure it out and all the other stuff, but you will find that it's in some very scary places. It uses a management frame, and that's how it broadcasts it out, right? So it just repurposes the managed frame, the discovery managed frames. Cool. This one, was anybody in here when I hijacked the phones a while back? Yeah, about 5 years ago, I hijacked the phones, and they almost kicked me out of the ISA conference. Nobody remembers that? I remember that. A few people do. So that attack has kind of been like, so yesterday? Well, we tried it on all the smartphones. This one actually worked. Even though it's connected to an encrypted wireless network, all you got to do is spoof the SSID, overpower it, and it'll join your network. Then you can just log in and take the passwords and do whatever you want, and then push it back over to the network, and then you can join the network. So it's kind of a cool little hack. I'm going to say it's about 30 to 40% prevalent in all IoT devices, even in enterprise networks. And when I say that, it's things like lights on, lights off, conference room controls, things that bring up and down projectors, all that. They all own the exact same operating system. So don't think that this is just a power plug problem. These are the OSs running across it. Anybody ever heard of the company TPLink? They've got a lot of devices. They use the same code on all the devices. Just know if you ever want to decrypt your traffic, it's 171. Right? He's confirming. He's doing a heck of a job. All right, so operating system here. We open it up. We located the FSC regulation information, which led us to the manufacturer wires board. Wires board is a UART interface for interfacing with device control. Next steps in this, like I said, we only did like 30, 40 hours training or testing. We didn't want to go too nuts. If we were going to go jump into this and we're going to hack the heck out of it, next steps will be reverse engineer to gain console access for further research, right? We also noticed that this thing uses a lightweight protocol TCP IP stack called LWIP, common open source stack for IoT devices and things like that. And they have a few vulnerabilities. This one wasn't vulnerable to anything though at that point. So, can I click the button? This IoT device is not working. It should have an IP. Every device that we looked at had security issues. So we looked at 3 devices. They all had security issues. That should be something that should send warning bells off on, right? And we literally only spent 30 to 40 hours doing this. Even though these are just power plugs, they accurately represent the common issues we find in other IoT devices. When we are getting into universities, financial institutes, so in data centers, man, you'll plug things in KVMs that are IP enabled, right? You'll know about those, but you'll also plug in devices that are doing things like key fob, swapping, encryption keys, stuff like that, and they will be IP enabled. And it won't be that the encryption algorithm and stuff that it's doing or the key management is doing that is vulnerable. It is that the stack that it's operating on is vulnerable, and that we will take that to then pivot. You guys know what DRAC is and all that stuff, right? You've seen that, remote session management, log into servers, that kind of stuff. Same exact thing, right? They had that whole hash issue. You just bounce it off the box and dump the passwords out. We're seeing that with all kinds of devices. In data centers, IoT is everywhere. They're monitoring everything from wind current between servers to temperatures to fans to lighting to everything. Humidity, everything. And it all has IP, right? Suddenly everything has an IP and your attack surface is, I don't even know, it's huge. So with that, I'm going to let him demo something really, really quick.
Can you go back the slides to the...
Which one?
The command structure.
All right, he wants me to show you something. He's got a request. 30 minutes he stood there, didn't do anything. Now he wants me to do something. We know who's in charge now. This guy. And Scott's only been with us for 2 weeks, 3 weeks? Yeah. This is his first project. I think he likes it. That?
Right there. Right,
this is it. One more.
Yeah. Okay, so what we did is we captured the UDP traffic, and with the static key that we found, we decrypted
Can you hear?
traffic. Test? Okay. So what we did is we captured the UDP traffic and then decrypted it with the static key that we found and found this command structure. So as he said before, phone name, device MAC, password, command, and request. What it does is, this comes from the app, it goes to the app, and the app replies back with a confirmation number. And it's the same style structure. Then you, from the second image down there shows the command, and then you just reply back with an acknowledge, and it runs the command. So what we did is we took this structure and wrote a Python script to send a command over, and just reply with an acknowledge with the confirmation number, and it controls the light. Over here on the side, we have one of the plugs connected up to a light, and we'll show you what the Python script does.
Do you have your little adapter for your laptop? That's not very good. What a van of white.
So the output from the Python script looks identical to this. So this is what you would see if I were to show you what was
So you
happening.
can't see his script because he forgot his adapter. I think he's in trouble. He's grounded.
So sending it the on command.
So he's
Turns
turning
the
the light
light on.
So what he just did was it's supposed to only be from a smartphone, but he sent it from his computer from a Python script he did. He sent it up to AWS and said, "Hey, AWS," and he's got a little wireless router that is connected out on our 4G network, whatever. That plug is out there talking to it. He sent the command to AWS. AWS said, "Okay," and then shot it down and turned the light on. And he's just going to turn it back off. Totally unauthenticated, right? It's just showing that it's not that hard. Yeah, and it went off. Kind of cool. This is why we didn't want to demo the whole thing, because it's actually kind of boring. we were like, hey, let's not do any slides. Let's just do all demos. And we're like, they're going to stare at a computer screen for 30 minutes and be like, what is that? So we made slides to make it a little easier to digest. Any questions? It was HTTP protocol. It was GET requests. We could never get it to go any further than just say who it was and the version and its location and stuff like that, like geo coordinates, stuff like that. So, and we didn't spend a lot of time manipulating it, but it just never went any further than that. Oh, the manufacturer of that plug is in China too. So I mean, most Chinese backdoors now though report back to AWS because it's too obvious when it goes to Beijing. See, now you want to get medically malicious. Now, we test some universities that do medical stuff and some hospital stuff and all that, and I will say these operating systems and things like that work as well, and we've tested devices. So it wouldn't be hard to not strobe somebody to have them a seizure, but it would also not be too unheard of to make robotic arms cut in the wrong places without going into too much detail.
Yeah. So to do that, all we would have to do is put this command, the on and off, in a for loop, and put some sleep functions in there.
So 2 more lines. 2 more lines and you go insane like the incandescent light, right? The other cool thing is if you do that with the project 5 or 6 years ago, I did a syslog spoofing project where I spoofed syslog messages on the internet. What you could do is take that exact code, throw this in there, and just emulate every single IP address that ever exists. And hopefully it's doing that in the entire city of New York City, right? You see lights going on and off. Then you get really cool and you tune it to Third Eye Blind, right? Or something else, right? Some cool song music, techno music, right? Yeah, now we're getting way far. Now we're getting into the yeah. Mr. Robot, right? Any other questions? Sir? Inductive loops? Low inductive. Oh, I have no idea, man. Are you triple E or double E or something? I'm like, huh? Oh, well, so we didn't mean to do that. Sometimes our actions have negative consequences. I know what a diode is. Another question? Awesome. No other questions. If you guys want to see the code or want to see some of the other stuff that we did or check out the Wireshark thing, catch us at the Matt Security booth. He'll show you whatever you want to see. The demonstrations are kind of not sexy unless you see it yourself. Y'all enjoy the conference, and hopefully I'll see you next year.